Hey there everyone, all the techies and data enthusiasts there. So guys, I'm back with a new playlist called Transformers Simplified. So not the Transformers which you are seeing on my background, of course even they looks cool, but these Transformers are the main backbone for all the AI models which you are seeing, and it's very important to understand the Transformers architecture in this AI era. If you want to learn data science or AI, so Transformers are really important for you all. So the ChatGPT, Gemini, Llama 3, Mixtral, and all the open source models you are seeing, or many other models which you are seeing closed source as well. These flux models and image generation models. For all these models, Transformers is a backbone, or you can say these are the base models. Without Transformers, it wouldn't have been possible to create all these revolutionizing models, you can say. So, guys, in this particular entire playlist, we are going to have totally 9 videos. So today is video 1 of our Transformers, which is introduction to Transformers. So from today, continuously we'll get for 9 days, 9 videos in this particular series. So with a great struggle and with a great efforts, we have created this content. I'm expecting you all to like this particular video and share this video with your friends, and do subscribe the channel and encourage us to create more videos like this. Now let's dive into my computer screen and discuss more about Transformers. So guys, this is your day 1 to understand Transformers. So if you follow me for this entire series, even you will be able to answer about questions related to Transformers very easily on your interviews. So I have created a entire series notebook, you can say Jupyter notebook, or the entire content is updated in my GitHub as well. You can go and check out this particular content. The link will be in this video description. So now let me go ahead. So understanding Transformers, what you will mainly learn in this course: introduction to Transformers and their history. So before Transformers, what were the models which we were using, and what are the drawbacks of those particular models, that we are going to discuss in today's video. And then Transformers architecture. So entire like 9 days, 9 videos, you can see here this 8. Okay, ninth video is not yet updated here topic, but it will be updated. It's nothing but final Transformers architecture. Okay, so first, introduction to Transformers and the history and Transformers architecture we are going to see, and we are going to explore the in detail about encoders architecture and decoders architecture. They are actually the sub, you can say, process for Transformers. And finally, what are positional encodings, feed forward neural networks, layer normalization, and residual connection. So we are going to see about all this. And finally, once again, we are going to discuss about the complete Transformers architecture. To understand the complete Transformers architecture, you should know all these topics. Okay. So why you want to learn about Transformers mainly? The main thing is it's the trend right now in the AI era. If you don't know Transformers, it's very difficult to crack the AI and even data science and machine learning interviews as well. So whether you want to enter into any of this field, you definitely require to know about Transformers and NLP. So why mainly Transformers? See, normally, if you're going to read a book, for example, you're not going to read one word by one word, right? You can take the example here only. You're not going to read transformer, have, revolutionized. Like this, you cannot read one by one, right? When we are going to read, normally how we humans read, we directly read. Transformers have revolutionized the way we approach sequence to sequence tasks. So in, you can say, the entire sentence, we can read it very fast. But when it comes to this particular AI models, right? Previously, they used to go in sequence, one word at a time. First, they used to take an image, then you are then reading a book. So one by one, okay, one word at a time. In RNNs, in LSTMs and GRUs, this is what used to happen. Before Transformers, these were the main models. Okay. So definition on types of neural network. So transformers are a type of neural network architecture designed to handle sequential data, particularly in the field of natural language processing. They are introduced to landmark paper like attention is all you need mainly. So before the name you are seeing right now, transformers, right? This is just the name given after attention is all you need. Previously, Transformers paper was called as attention is all you need, and the paper you can find out easily if you just search for attention is all you need. You will immediately get the paper at the first itself from RX. Yeah. So if I click here on view PDF, immediately I'll get this PDF. So you can see here, this is the transformers architecture, and you can see here it was introduced by Vasavini, and she is a member at Google DeepMind. You can say this transformers architecture which you all are seeing, it was mainly introduced by the members of Google, you can say. Okay. So unlike traditional models, the process data in order, transformers can look at the entire sequence of words simultaneously, allowing them to capture relationships and context more effectively. So previously what these RNN models used to do, so one word at a time. They used to, if you give an entire sentence, it used to take approximately 10 minutes to understand one word at a time and again process them and again make it into a normal sentence, and to understand it used to take more time. But here in transformers what it used to happen, so entire data it used to take at one sequence and understand it very soon in a format. That's mainly because of their positional encoding that I'll tell you in detail when we go forward with it. Why are transformers significant? Introducing long range dependencies. Traditional models like RNNs struggle with long sentence because they process one word at a time and often they forget. So the main problem with these previous models which we are having, right, RNN and LSTM and GRU. So LSTM and GRU are nothing but advanced version of RNN. Okay. So previously what these RNN models used to do, if you are started to read something like, for example, see, transformers are a type of neural networks designed to handle sequential data. So within the time you come to sequential data, that model will forget the first sentence, that is transformers are a type of neural networks. This it will forget. There was a lot of data used to be like vanishing gradients problem used to be there. Transformers, on the other hand, can consider all words in a sentence at once. So they are one word at a time. But here the entire sentence it can capture at once itself, making them much better at understanding the context. Attention mechanism. At the heart of transformers in the attention mechanism, which allows the model to focus on relevant parts of the input without making predictions. This is akin to how we humans pay attention to certain words or sentence in crucial understanding. Like to say you all easily, right now you can imagine RNNs, LSTMs and even GRUs. They are a kind of a small baby, a first standard or a second standard kid, you can say, who is struggling to understand English one by one word they are reading, and they are understanding not only English, any language. It can be French, it can be Hindi, Kannada, Telugu, Tamil, any language. When they are starting to read what they'll do, they'll understand one letter at a time, then the entire word, then the entire sentence. They follow this process. But we, once we are experienced, what it happens to us, so we'll directly read the entire sentence at once and we'll understand it. So this attention mechanism is very crucial, and you can say transformers are like us humans. Transformers architecture is designed in a way like our human brains are there. So it can easily understand and process the entire sentence at once. But these RNNs and LSTMs are nothing but they are like your, you can say, kids studying on schools or colleges who like very difficulty they understand the sentences. And after this, parallel processing. Transformers can process all words in a sentence simultaneously, which significantly speed up training and inference time compared to RNNs that operate sequentially. And the parallelism is the main game changer for this. When it comes to a large data set, when you have 1 million, 2 million, and even trillions of data sets, then you cannot sit and load one data at a time, and you cannot wait. When there is no parallel processing, you have to load one by one. It takes more time to understand and training as well. But when transformers come in, then it does very fast. So you might have observed, right, even in our Llama 8B model, 8 billion parameters, 7 billion parameters. This is all because of transformers architecture only. When there is a base model which is able to do parallelism, parallel processing can be done, and which is very fast in inferencing, and with good GPU, how much ever billions and millions of parameters it might be, it can train very fast. Even NVIDIA is the main key for this. After the launch of NVIDIA's RTX GPUs, this transformers and this LLM models have become a game changer. Versatility. While transformers are initially designed for NLP tasks, Their architectures have proven effective in various domains, including computer vision and audio processing. This versatility leads to the widespread adoption across the different fields. So because of these transformers model which was introduced, the base model, because of this now we are able to do computer vision detection, like for example helmet detection, or the humans who are visiting and using the cameras, they can detect it, track the person. And even our Tesla cars and all these automated cars use the computer vision 360-degree camera view. How they are able to view this all is a game changer AI technology, and the main base model is our transformers. And after this, our audio processing, like cloning the voice. Just you give the sentence and it will automatically create voice of whoever you want. Example, there was a trend previously, like people used to create multiple songs on lyric generator. I guess it was a lyric generator where you just upload a file with the lyrics, and it can be in various audios. It can be related to Narendra Modi singing some song, or Virat Kohli, or any celebrities who want to sing. Even Trump used to sing. So that was a game changer. Many videos were circulating on the internet as well, you guys can check out. So for them all, the transformers was base. The evolution of neural networks leading to transformers. So previously we have RNNs and other things, right? Before that also there was a neural networks, like we have ANNs, CNNs, and many more, like basic neural networks also were there, simple feed forward neural networks in the early days of neural networks. So the researchers have dreamed of creating machines that mimics human brain and process. The dream began to shape after the advent of neural networks, computation, and models inspired by the human brain. So, in short, this transformers architecture or the neural networks is right. It is nothing but it's a mimic of human brain. What we think and how we think, the same way the LLM models can think. So they have created a shape for that, and now it's going on and going forward. But there is one drawback with this LLM models and AI models is that we have to feed the data and we have to train it. Still, they don't have any self-thinking capability like how we can think. But going forward, still there is rumors going on related to AGI. Like people are telling that very soon the AGI might come in. What is AGI? Nothing but artificially generated human intelligence, where the models have the capability to self-think. They can think and even they can do tasks, and with the parallel processing. In short, it's like you yourself talking to someone, and how we think, even the LLM models will have that capability to think. But there are some drawbacks for this as well and some advantages as well. We are not going to discuss deep on it. Entering into recurrent neural networks, which are nothing but RNNs. To tackle the challenge of sequential data, researchers developed RNNs, recurrent neural network. RNNs are nothing but the interconnected nodes that pass information from one to next, like a rally race where each runner hands off a baton. The design allows RNN to maintain a shot of memory for previous input, making for best suited to task evolving tasks involving sequences. However, RNNs have their own limitations. Short-term memory, as I told you all previously, short-term memory. So while it completes the entire page, when it goes to the next page in a book, then the previous page it will forget. So that forgetting memory or the short-term memory is one of the main drawback for the downfall of RNN. And vanishing gradient problems. During training, RNN can experience vanishing gradient problem, where the gradients used to adapt the networks become too small. This makes it difficult for the model to learn long range dependencies. Means there is a more chances that it forgets some words, and even it forgets some data whatever we have taught in between while training. So there is most of this vanishing gradients problem. The rise of LSTM and GRU. To address this issue, researchers have introduced long short-term memory network, which is nothing but LSTM and GRU, gradient recurrent neural network. Thinking of LSTMs and GRU as advanced version of RNNs, equipped with specific mechanism to maintain memory more effectively. LSTMs. These networks have a more complex architecture that includes the control of the flow of information. So here used to have a very different architecture. They can design what to remember and what not to remember, or what can be forgotten. So this allows the model to capture long range dependencies. Here mostly you will be having three gates. One is input gate, output gate, and even forget gate. So this particular model, what it will do, it will decide like whatever need to be forgotten, it will forget. Only which should be remembered, only that will be remembered. So imagine LSTMs are skilled librarians who have exactly knowing which book to keep on the shelf and which one to return to the storage. So it's like somewhat a book, or even you can imagine of yourself, like whatever folders you require in your laptop, you keep them in one side. Whichever is not required, you will move them to recycle bin. Okay, this can be an example. GRU. Similar to RNNs, GRU are a simplified architecture that combines the gates like the LSTM, younger siblings, less complex but still very effective. GRU has the ability to capture long range dependencies while being computationally more efficient. In short, what is the main difference between this LSTM and GRU is, in GRU, it is very less effective, in a sense, like whatever you are going to give and tasks you are going to train, right? It is very less computationally, very less time consuming. It is very fast and it can complete the task very soon. To say in short, if you feed a data to both LSTM and GRU, in LSTM it might take 30 minutes to complete the training, while in GRU it can complete within 20 minutes. So the main reason for the GRU to be more popular compared to LSTM is it can reduce the inferencing speed, it can cut down the speed, and it can complete the training very fast. 70% time only it takes. Despite this advancement, both LSTMs and GRU still have their limitations. They process sequence of one step at a time, which can be slow, especially with long range dependencies. This sequence processing means they take full advantage of modern software and thrive on parallelism. So in short, still after all these limitations which RNN was having, they overcome. Still the main implementation, or the main limitation was left out, which is nothing but processing one word at a time in a sequence. That was not been able to solve by LSTM and GRU. Then transformers entered into the game. This is where transformers came into play. Introduced in the paper, attention is all you need. Transformers broke away from the sequence processing paradigm. Instead of relying on the memory cells like LSTM and GRU, transformers brought a new approach to sequence modeling by leveraging the attention mechanism, allowing them to process entire sequences simultaneously. By doing so, transformers not only capture context more effectively, but also they enable parallel processing, leading fast training time and better performance on long range sequences. This break opened the floodgates of advancement of natural language processing. So once the transformers came into picture, the entire AI game got changed. So all the latest LLM models, AI models, GPTs came in, BERT came in from Google, and even you have T5 models. All these models, one shot they came in, and the LLMs and even the NLP became a very huge demanding skill previously and also at present. Now also, if you know NLP and data science and AI technologies, you will be paid very well. So guys, before we move for our next video, I have one question for you. This transformers model was introduced, that's fine, but I mentioned you all, this is called as a black box model. Can you all just comment below, why is transformers mainly called as a black box model? So guys, meet you all again tomorrow in my next video.